Hi, I am Anindita Dash Bhattacharjee. In the previous video, I have discussed on CTS technical aptitude test patterns, also solved some critical automata fixed problems. In this video, I am going to solve another automata fixed problem on Pythagorean triples using shortcut tricks and detailed explanation. Let's first understand the concept of Pythagorean triples. Here is the problem where input limit is given and you have to generate specific output, which is known as Pythagorean triples. This is one of the most frequently asked automata fixed problem in CTS Drive. Ideally, you need three nested loops to code this program, which encounters complexity of order of n cube. However, I will provide you a shortcut tips and tricks to code this one. A Pythagorean triple is a set of positive integers a, b and c that fits the rule a square plus b square is equal to c square, and when we make a triangle with sides a, b and c, it will be a right angle triangle. C is the longest side of the triangle called hypotenuse. A and b are other two sides. The famous example of the Pythagorean triples can be explained with the help of the numbers 4, 3 and 5, that is 4 square plus 3 square is equal to 5 square, that is 16 plus 9 equal to 25, and other two examples are 5, 12 and 13, which will give you 5 square plus 12 square equal to 13 square, and 9, 40 and 41, where you will get 9 square plus 40 square equal to 41 square. So we have endless number of Pythagorean triples, but the trick here is we can prove this with the help of Pythagorean triples, which is generated first, that is 4, 3 and 5. Let us consider an integer n. For greater than 1, we will get 3n, 4n and 5n, and this is true because 3n square plus 4n square equal to 5n square. So for n equal to 2, we will get 8, 6 and 10, which will give you 64 plus 36 equal to 100. Hence the next triples are 8, 6 and 10. Now, within a given limit 20, we have generated the first set of triples 3, 4 and 5, and also calculated the next set of triples 8, 6 and 10. To generate next, I will use a trick. According to Euclid's proof, we know that if I take two consecutive numbers like 2 and 1, and if I square them up and take their subtraction, and then we will find a number which is an odd number. For an example, if I 2 and 1 and square them up, and if I subtract them, then I will get 3, and for 3 and 2, if I square them up and subtract them, I will get 5. All are odd numbers. So now I will formulate this concept by writing a is equal to m square minus n square, where m and n are two consecutive numbers, and as a result we will get 3, which is definitely a odd number, and I will use this formula to code my C programming. Among first triples, how 3 can be generated we have already discussed. Now our topic of discussion will be how to generate 4 and 5. So this is the first formula that we have used to generate the number 3, which is an odd number. Now, how to generate 4? For generating 4, for the value m equal to 2 and n equal to 1, I will use the formula b is equal to 2 into m into n. Then I will get 4. So I will use this formula as my second formula in my coding. Now the next part is how to generate 5. The 5 will be generated for the value of m equal to 2 and n equal to 1 using the formula c equal to m square plus n square. Then this is the third formula that we will incorporate in our C programming. We have to use all these formulas iteratively to generate next set of triples. That is, we need a for loop. Now, all these conditions are tested under the value m is equal to 2 and n is equal to 1. That is, in your coding, n should start from 1 and m should start from 2, and the value of n is less than m. So put all this condition under your partial code and the formulas should be written inside the for loop. See, this is your partial code. One thing I want to mention about this loop is why it is plus plus n. Remember, since n starts with 1, I need this loop to be executed one time less. As my point is, since 1 to 5 is 4 number and 0 to 5 is 6 numbers. So remember this point. We have to generate the triples within the limit 20. Now, my point is we have to take a variable limit which will hold the value 20, and since it is the only prominent condition we will have, it is better to use a while loop where c is less than the limit. Why c? Remember, c is the variable in which we are calculating the third formulation of the triple, and this loop will break when the value of c exceeds the limit. All the concepts are combined together here to form the nested loop. Means here the for loop is nested within the while loop. Now here the question is n is incrementing, c is incrementing, when the value of m will be incremented and where. See the position where the value of m will be incremented immediately after the for loop but before the end of the while loop, because for loop is controlling the generation of the first or the second or the third sets of triples like 3, 4, 5. So immediately after generating the first set, m is responsible for generating the next set. So for that reason, the value of m will be incremented by 1 and it should be incremented after the for loop. And this is your partial code. In CTS drive, under Automata fix problem, you have to write the discussed code under function f, where limit is passed as a parameter and main function will be given. Now here trick number 2 is you have to remember that no return condition was given. So as a result, your function f should have the return type void.